So, good morning and welcome back. And I'm not sure what I'm looking at right now. Oh, okay. Good. So, any questions, any comments you might have for the exercise, for the assignment, or anything else before we get started? No? Okay. So I have some comments. Some people, I had to comment it to some people. What they did is so we had the task of taking a file from the command line and then reporting how many characters, how many lines, and how many words are in the text. And of course, I didn't check for exact numbers because it all depends how you exactly calculate, especially words and so on. And but one thing that happened to several people is that what they did is that they wrote three functions that each one of those functions received the name of the file, opened the file, read the content of the file, and then did the calculation, each one of these three numbers. And that's sort of fine. And no one really notices at this file size that it's wasteful. But if you had to do this for large files or many large files, then you might notice that it takes some time. Okay, now it's not a huge waste of time, but at one point you might want to think a little bit more about optimization of the code. I wouldn't even call optimization. So the point is that any calculation that you do in memory is way faster than any interaction with the hard disk. Okay, so all the data, all the files are located on the hard disk or SSD if that's what you had in the computer, but it's an external storage sort of. And that when you read them into the memory, that takes time. And it takes 10 or sometimes even 100 times more than any operation inside the memory. So reading 3 times the data from the disk means that you have the incur this cost 3 times. So it's better, usually it's better just to read the data once, and that's one thing. The other thing is that I think almost everyone, or maybe everyone, what they did is that read in the whole content of the file and then operated on the whole content as one long string. And again, this is fine because in our case, because the file itself was small. But each one of you has a certain size of computer with a certain limited amount of memory. So if the data on the disk is in the file is larger than what you have in the memory, then you will run out of memory and you won't be able to do this computation in memory. So it would be more, it would be better, or actually it would work if you did it line by line. So we also saw it last week that how you read in line by line the data, and then you can operate on that line. You do the counting of the characters and the counting of the words, and obviously you just have one line then, so you add them up, and that's how you can count. So it might be longer than some of the programs, some of the solutions that people made, but when the file is big, this is the only solution. You can't read the whole content of the file into memory. And let me talk a little bit about this, and I don't know, should stop. What doesn't matter. Actually, maybe I will find you some pictures of a little bit about computers. So it's important in some of the earlier courses, people ask me once in a while okay, they are about to buy a computer, and what would I suggest? And it was a good opportunity always to tell a little bit about computers, so you have a little bit background. And one of the main things that I want to talk about is the notion of memory. So today, if you go and buy a mobile phone, okay, they always talk about having it, I don't know, 64 gigabyte of memory or 128 gigabyte of memory. This is not what usually we call actually memory. This is sort of a marketing ploy, and this is actually confusing. There are basically two main storages in the computer. What computer people call memory, or RAM, random access memory, which is usually small relative, and it's only available when the computer is actually on. And then there is the external storage, or hard disk, or SSD in the last couple of, I don't know, 10, 20 years, where you can store data for a longer period of time, and it remains there even if you turn off the device. So when they're talking about, so in a computer today, okay, in a computer like mine, you might have 4 gigabyte or 8 or 16 gigabyte of memory, and hundreds of gigabytes or maybe even a terabyte of hard disk where you store your images. In a mobile phone, when they're talking about, I don't know, 64 gigabyte, that's the storage, the long-term storage. The random memory, the random access memory, so the memory that is in use while the device is on, is usually 2-4 gigabytes top. Well, maybe there are the new phones maybe already have 8 gigabyte, I don't know, whatever. But 2 or 4 is I think the most common one in that. So but the marketing people, so they rarely talk about it. So I don't. We can look at this website if you're GSM phone. What is the website? I don't know. I don't remember the name. This is okay. This is the website. So I don't know, Samsung, whatever, A55. I just picked one phone. So it talks about memory, okay? Even here it's called, they are calling it memory. But you can see, let me enlarge here. They're using the same word memory, and then they are saying that there's a 128 gigabyte and 6 gigabyte RAM. So that's the 128 is the same as the hard disk in your computer, or I mean, in notebooks, they are not these days, they are not hard disks anymore, but these SSD things, which they don't have moving parts. And this is the large, and this is the random access memory. So the first one here in this image, in this on this web page, is basically how many pictures or whatever, how much data you can store for long term. So even when you turn on the device, this one is relevant. How many things you can load, you can run at the same time. Okay, so when you run your computer, and these things, they are the same on computers. Basically, a phone is just a computer. It just was easier for me to show it here. And then I don't know, whatever, you got all kind of other variations here. Okay, so the RAM part is relevant of how much data, how many things you can do at the same time. So let's say you have you did an experiment, okay, and in the experiment you got lots of Excel files, and they are all stored on the hard disk somewhere. Okay, so that's fine. It's a lot of space there. But now you would like to analyze all this data. In order to analyze the data, they have to be loaded into memory. You might remember we talked about opening a file. And I told you that in the Visual Studio Code or in Microsoft Office or whatever office you use, opening means loading into memory and displaying that. Okay, and for for programmers, opening is only the connection, not yet loading into memory. But in order to analyze the file, we have to load it into memory. So load it into this memory, well, this one, the smaller one, the random access memory. Okay, so the more of these memory you have, the more things you can analyze at the same time. Okay, and that's what I was talking about, the loading of the file, the whole file into memory, or only some of the files. So you need to remember that this thing, the 6 GB memory, must contain everything that the computer does. So I am running now Linux, so I can show you this one, the htop. People with Mac probably also have this command. Windows, I forgot what it's called, but the resource manager, I think it's called. There is a software on Windows as well that can show you all kind of information. Now, what you can see here is that this one is the random access memory. Okay, so this is what the smaller number, what is only available while the software is running. So you can see where the computer is turned on. So mine is actually a big computer. It has a total of 27. Why it's only 27? I bought 32. I don't know, whatever. Some of the is only available, or maybe that's the free. Okay, it's now showing only the free, maybe, I don't know. So this is now using 5 GB of memory. Just by, what do I have it here open? The main thing that I think is actually using is Zoom. So here you can see the details. This is the software that it's running and how much memory it's using. It's in percentages, and how much of the CPU it's using. Okay, and that's another story I'll talk about a little bit. Okay, so this is what the memory uses, but it's already using 6 or 5 point something gigabyte of memory. So if your computer, my previous computer that this one I bought less than a year ago. Okay, so the previous one had, I think, 8 GB memory only. So it would almost run out of memory already just by having Zoom open, and I think a browser and the terminal, and that's it. So you have to you understand that you need a lot of memory there. So that's one thing that needs to be considered when buying a computer. And when you're programming, you have to think about the fact that the memory where you can load the data is rather limited. Okay, and also you will see that in sometimes if you have a problem of lack of memory, the cheapest, easiest thing is to buy more memory, buy a computer with more memory, whatever. And if you're working on research in Weizmann, there is the VACSAC. The VACSAC is a cluster of many computers that you can use, and they have way more memory than what you would probably have on your own computer or even in the lab computer. So that's one aspect. The other main aspect is the CPU. Okay, so here, if I go back to the here's the CPU. Oh, actually, I also have to talk about the GPU. So the CPU is the central processing unit of the computer. That's the brain of the computer. That is the part that does actually the work. And then you usually refer to some kind of gigahertz there. Okay, so there are in the computers there's the i3, i5, i7. There is that's for Intel, and then there are the AMD chips, and these are the CPUs. And then you usually have a number and then some speed or frequency. Okay, and in general, the higher these numbers, the better. It's not always, but in general. But there is another thing these days, is the number of cores. Okay, so the CPU is the one that does all the computations or does all the work, okay, for now. Okay, later on I'll talk also about the GPU for a moment. Okay, but this is what does all the work. So the faster it can work, your computer will be faster, right? That's one thing. But you probably hear about cores. So in the old days, like 15 years ago, 20 years ago, basically you had one CPU in every computer, meaning that it can do only one thing at a time. Okay. These days you have many cores, and here for example, it says it has four cores. So basically 4 CPUs. It can do 4 things in parallel. So maybe the actually frequency is lower, but because one computer has more cores, it could actually or could do actually more things in parallel. And when I run this HTOP, at the top here, you can see numbering from 0 till 15. That's 16 cores. This computer has 16 cores. It's a pretty powerful computer. The previous one I think I had there, it had only 4. Okay, and these days the mobile phones have 4 cores easily. Okay, so that's another thing that you have to either consider when you're buying something or even when you're using how many cores. But so far what we wrote and for long and basically all these cores, but we're going to only write programs that cannot reuse the idea of having multiple cores, because so far we wrote only programs that's just one process. Okay, in order to be able to enjoy the fact that we have multiple cores, that in order for your program to really enjoy that, you'll have to write it in a way that it will do things in parallel. And that's not easy, because then you have to make sure that all these parallel things somehow come together and the results get together. By the way, if you've any questions while I'm drinking, think about it and ask. Or even when I'm not drinking. So that's a thing that you will have to take care especially when you're getting to do more complex stuff that takes a long time to process, is how you could make it parallel. And for example, let's just give you an example. You have again an experiment. You received 1,000 Excel files, and each one is big, and you have to do some computation on each one. You can do it sequentially, right? Each one, let's say, takes 1 minute, okay, to analyze. So you have 1,000 files, that's 1,000 minutes. I don't know how much is that, but it sounds a lot, okay? So what if you have 16 cores and you could divide it into 16 different separate tasks? Then each one could work in parallel. Okay, so you can divide by 16 that 1,000 and get, I don't know, 80, 60, I don't know what it is. Okay, whatever. So way less time to do the job. So it might be worth investing in that, in learning how to do that, and so on. And what else? Actually, so even without us doing this parallel processing, we already enjoy a little bit the fact that we have multiple cores, because the computer, let's say now Zoom, the computer does all kind of tasks. So I can't turn off Zoom, of course, but if I scroll down, I think you can see many other tasks that it's doing. Okay, so the heaviest ones are Zoom. That's why it was on the top. But the computer is doing lots of other things. It's listening on all kind of things that might happen in the computer. So the keyboard, the browser is open, whatever VS Code might be open, and so on. So there are hundreds of these processes running in the computer at the same time, just so the computer can run, even without us doing any work. So those can already work on the separate cores, separate CPUs, basically, and that can all allow that your process will get the full capability of one core in that case. So that's one thing. And then one other thing that I wanted to mention here that I saw and it reminded me, where is it now? I lost it. Here it is, CPU. So there is the GPU. Okay, so what is the GPU? You might have heard about the GPU in the recent years because it became popular recent years. So many years ago, when the computers were relatively weak, at one point, the designers of computers figured out that in order to draw on the screen, we were using, I mean, just to display whatever you wanted to display. So all this image, all this thing, it's basically drawn on the screen. So the screen is just one big picture, lots of pixels, and the computer is always drawing on the screen all kind of stuff. And they figured out, and it was the job of the CPU, of the central processing unit, to do all these calculations and draw on the screen. And then they figured out, well, drawing on the screen is actually a very simple and stupid thing. It's just mathematical calculations. And we could create a much cheaper chip that will be able to do the graphics. Okay, and that's why they created the GPU, the graphical processing unit. That's why it's called GPU. So the original intention was that it was a very stupid thing. It can't do all the complex stuff that the CPU can do. It can only do mathematical computations, but it can do it much faster than the CPU. And it was the original intention, and they were really weak. And then a couple of years later, about, I don't know, 5 years ago or so, when this whole machine learning and AI started to become a thing, suddenly a lot of these mathematical computations were needed. And suddenly, this thing that was originally created as a stupid, just putting things aside, became something really important. Because lots of these mathematical calculations that people are doing now, and basically all the AI is just that. Okay, it's just very fast computation in mathematical functions. And suddenly, because of that, the GPU became important. So these days, especially if you're doing that kind of stuff, it's important what kind of GPU you have in your computer, because it's not just the drawing on the screen, it's suddenly a lot more things. Okay, so these are, I think, the main features that your computer has and your mobile phone has, and it's important. And of course, for mobile phone, there are all kind of other things that you think, and also for computer, but these are the most important ones. And one more thing that I note, I mean, I think it's still the case that when you go to buy a computer, the emphasis is usually by the seller is on the CPU. How much CPU power? It's much faster. It's an i7. It's a whatever. And they don't talk much about the random memory, the RAM. Okay, and in most cases, it's better to invest in more RAM than in a faster CPU. Okay, but it's because the bottleneck, as I noticed, in most computers that are sold on the market is the memory. So the computer can't go faster because it can't load enough data into memory. And as I mentioned at the beginning about the disks, doing any work inside the memory it can be like 100 times faster than going to the external disk, loading into a data in order to do the computation. So if you can load more data into memory because you have more memory, your solution will be much faster. Okay. Any other thing I wanted to talk about? Not really. Okay, so let's do something with our code. I'll get started. I'll go back to the command line. And we had the day 3, I think, day 2. day 4. It was day 4. Okay, day 4. Fibonacci. Okay, so let me check it just where is it, because I would like to use the Fibonacci. So, okay, I'm going to copy this one now. So I'm going to copy this to day 5, so I can work on that. And so I'm going to open the Fibonacci in day 5. What do we have here? We have here the main function, okay, which is called at the bottom. And the main function then calls the Fibonacci function in 2 different places. And I just made I had a typo in the name of the function. Okay, let's get first. Let's make a little bit of. Let's leave it for now. Okay, so now what we did here is created a function and then called that function from the main program, but we didn't really see the reuse of the function. So let's say let me comment this out now for a second and change a little bit this one. Also, I'm going to okay, let's just do it like this: 7 and 3. Okay, without the. Let's do it this way: n equal to 3 and n equal to 7 here. So in this case, okay, and I don't even ask the user anything. I don't expect from the user any values. This n, I don't care about it for now. Okay, so now what we have here is a clearer way of we are reusing this Fibonacci function, because for whatever reason we needed the Fibonacci number of 3 and the Fibonacci number of 7. Let's go even further. Let's create a new function that might be even clearer in this reuse, because sort of Fibonacci, if I calculate 7, I already calculated 3, so why would I need these both? Might be unclear, but let's create a function that says area. Now add. Okay, it gets 2 values, and it's just a very simple function. It adds together these two numbers, 2 values. Okay, so now we could come here and say, okay, print add 2 plus 3, and then I can also call it with I don't know, 7 and minus 3, and let's run this program now. Okay, day 5 here, and if I run this Python, it's called still Fibonacci, and I should call it Python 3 because that's how it's called in my computer. So it gets me 5 and 4, and did it do it correctly, the addition? That's 5 and 4. Okay. So now you could see that I reused some function, the add function in this case, for the various computations. And it's very simple, but that's how I used it. But right now, I can only use this function inside this file. Okay? How could I now allow other programs to use these same functions, the Fibonacci function, the add function, and so on? Okay, so the way is that we are creating modules. I don't know what is here. Let me just close it. Another version of the Fibonacci, I'm closing it. Okay, so we're creating modules, and the module in Python is basically just another Python file like we had so far, with the .py extension, but the main difference is that it only has functions in it, and it doesn't have this calling of any of the functions. It just has the functions. So let's create one of those. Okay, let's take the add function for now. And I'm creating a new file, and I'm moving this add function to this new file. And saving it in the same folder, so the day05 folder. And I'm going to create it, call it, what shall I call it? My math. Okay. The name of the file doesn't really matter, except that, well, it should reflect what's in there. So I'm not sure if it's a good name now, but it's a name, okay? So it should reflect what's in there. And it shouldn't be the same name as some other common library. So that's why I used my math and not math, because I think there is a library in Python which is called math. I'm not sure, actually. Quite likely there is somewhere a library called math. Okay. So I have this my math. How can I use it now? So it's not in here now. If I run this program again, it will fail. Okay, it will say, okay, I don't know what add is. Okay, and we'll see the same with the Fibonacci. So it doesn't know what add is. So how can we get add? We can import it, just as we imported the sys module. The sys is just a module like this one, written in probably somewhere in Python. Okay, so there is somewhere a sys.py file, and this is what we are loading here. So I can say import my math. Actually, let's do it in a different way. From my math, import add. Okay, this is one way to import it. I'll show you the other ways soon. But because here inside I already used the add function, I thought that this would be the easy way. So what I'm saying is that go find the mymath module, and from the mymath module import the add function. So now I can run the program and it works. Because what I say, okay, find that mymath.py and import the add. Now I have the add function. So when Python comes here, it will find the add function because it was imported from somewhere. The Visual Studio Code, I can even click here somewhere. If I find the add, I think I press control and click on the add, and it will jump to where the definition is. And I think Control Shift underscore, no, Control Alt underscore. I never remember this. Control Alt underscore jumps back. Okay, this is a Visual Studio Code thing, nothing to do with Python. It's just a feature of one of the plugins that you can. So I press Control and the name of the function. First of all, you can see here what we call the signature of the function. So what kind of parameters it's expecting. Okay, but if you click on it with the mouse, then you can it actually jumps to the definition of the function. And then if you would like to go back where you were earlier, of course you can find it here, but you can also click on Control Alt and underscore. Okay, Control Alt and underscore, and then it jumped back. Now I don't know how it's on Mac. It's and this is on Linux. Probably on Windows is the same. The Control Alt underscore. I don't know it's on Mac, but let's see. VS Code keyboard shortcuts. Okay, it's not the first time I'm looking for it. Okay, you can find it. Okay, this is a PDF file apparently. What it has here. Okay, let's see that one. Okay, so this is for Windows. Okay, this is for Windows. Let's see if there is one for shortcuts for Mac. Okay, I guess there is one. Okay, and that's another PDF file. So I recommend that if you're using a lot Visual Studio Code, then you get used to some of these shortcuts because they are extremely useful. I'm probably your Control-C, Control-V, you Control-X, you already know, so because it's so common. But it's recommended that you learn about these things for the editor if you're spending a lot of time in it. Okay. So now what we have here is we moved this file, and so now I could write another program. Let's create another program, new file, and here what I'm going to do is import my math, and then I'm going to use this my math in a bit, but I would like to save it. So I call this program again. It's in the days05 library, and I'm going to call just add numbers. Okay, this is the program, and I'm going to. And how can I use this add now? The add function. I need, because I didn't write what I wrote here, not here, here. Here I wrote from my MS imported the add function. Here in the new one, I wrote import the my MS. Now I don't have the add function here. If I type it, I don't have it. What I have here is the my math library. And if I click dot here, then it will offer me the list of all the functions it has. There are all these things that are standard in everything. Don't worry about them. Here at the top, you can see the add function. So I can click here, and then I can open the parentheses, and it already offers me help, some explanation of what's in there. So I can now try 7 and 8, and the whole thing I let. Sorry, I just keep forgetting this let. Okay, and print the res. Okay, so now I can run Python 3, and this is called add numbers, and here it is 15. You can see it's at the bottom, it's 15. Okay, so this way I could also use in another program the same function. So now I have a library. So I have a file that acts as a library. It doesn't really have any difference from others, except that it doesn't have any code in the body, like here. In the body of it only has functions. Well, one function. Okay? Any questions here?
Yes. Can you hear me?
Mm-hmm.
It's working, both ways worked for me, but when I use the Visual Studio Code, I don't have the suggestions. Like you showed, you wrote my math, and then it suggested you to use add or something. For me, it doesn't show it.
Let me see.
Is it like a...
That probably comes from one of the Python extensions. So I'm looking for what I have here. This is what I have. This that one that comes from Microsoft. So I clicked on this this whatever it's called, cubes. I don't know. It's the extensions thingy of the Visual Studio Code. Are you, by the way, on Windows or Mac or?
Yes.
Windows.
Windows.
Okay. So it should be it should be the same.
Okay.
It was just general knowledge.
I will try to look for the extension. Okay.
Do you have this extension?
I will try to look for it.
Well, so just open it, and we can look it together. It's not just you. I'm quite
okay.
other people have the same issues. So let's can you share the screen?
Yes, of course.
Okay. I'm just asking if you don't have anything else on the screen that you don't want to share.
No, it's fine.
Okay.
No top secrets.
Yeah, it's not that. It's just you can. There can be private things that you don't want to share on a video or with other people.
No, it's fine. Wait, I'm struggling. Wait 1 minute. Okay, can you see my screen?
Yeah. So
you're talking about...
That's the one, and it seems that you have it installed, right?
So
that's what it says. It also says the Pylons is installed. Maybe they are getting confused. So can you show me again what the... So you have import my... Yes. It has some curlies underscore the MyMess. Can you put the mouse above it to see what's the... Wait a second. Import my could not be resolved. Oh, so it can't find the IMS library.
But it worked for me. Like when I used it here, you see it's working. That's
Okay.
weird. Wait, let's try another number. Let's see if it still works. Yeah, it's working.
So for some reason, the Visual Studio. Wait a second. What is this restricted mode? This is something that you can you see it, or is it only on my screen? At the top, I see restricted mode.
You see?
Can
Yeah,
you-
I see it.
Okay, so I think what I'm not sure about this, but I think what the Visual Studio Code does, okay, it in order for these things, I think I'm not sure, but we'll see it soon. In order for this, it has to run the code as well. So Visual Studio Code itself, because at the bottom it's you running the code. In order for some of the things to Visual Studio Code to be able to do, it itself needs to run the code. But by default, it says I don't trust the code unless you, the person, tells me to trust this code. Okay, because it can be code you downloaded from the internet and you might not trust it because who knows what does the code do, right? So click on the manage now. Let's see where, and I think scroll down. You can scroll down a little bit here. No, scroll down a little bit.
Yeah, I'm trying.
You can't.
Yeah, trust.
Yeah. And now I think it will trust the files in this folder or whatever. Okay, you can click on the X of the workspace trust at the top. And you might need to resave the file or just make some editing, a little editing. Just make some changes. Change the number, okay? Because it has to.
Okay. Yeah, I changed it.
Can you click on Quick Fix? Here you can see the Quick Fix in the pop-up. Yeah, but we don't want to suppress the warning. No, we want to we want it to be able to figure out where my mass is. Very strange. What if you close the file? Can you close
Yeah.
Yeah. Actually, maybe
And open it again.
So do you have did you open the folder or are you just opening the files?
It's all in my Python folder. Like it's all together.
Suggestion, you close the whole Visual Studio Code?
Yeah.
Wait, don't actually. Okay. Open it again.
Wait, I stopped
the sharing is also
somehow.
stopped.
Yeah, okay. Can you see my screen?
Yeah.
Okay, let's
so open Visual Studio Code. Yeah, not that way. That way, yeah. Maybe that might be another issue. Okay, so now close the files, the two files, just close them. That one as well, and say open folder. In the blue, there was a big blue button as well, but it also has no problem. This works as well. Okay, and now you are in the it's not a good idea to call the folder Python, but that's okay. So select folder at the bottom. Wait a second, actually. Do you have your code here in this word Python?
No, why don't I see it? This is strange.
Okay, so go where your files are in this.
Here, usually. It's in Word, Python. Usually it's here.
No, okay, so it's it doesn't show the files. That's fine. So select the folder at the bottom.
Okay.
So the thing is that Visual Studio Code, and now you're trusting. Okay, now go and say and trust. Okay, there was the big trust button. Wait a second. No, go back. No. Wait a second. No. Don't open the file. Did you click on the big trust button? No.
Yes,
right?
I did.
Okay.
I did.
Let me just try to explain. So if it's Visual Studio Code, you can either edit individual files, okay, and then they are sort of unconnected, not connected to anything else, or you can edit projects. Basically, you open a folder and then Visual Studio considers everything in that folder as the project. And then it sort of things belong to each other. So I don't know if this is going to be solving the problem, but let's open the file that you're editing. The try. Yeah.
I think it
Okay.
was this one. Yeah. Yeah, it worked.
Okay. Let's try and then
Nice.
yeah. So that one, and then try it. Start just typing ed. You can start ed and open the parentheses. Open.
No.
No. Oh, wait a second. No, because you didn't import ed. Type in mymess.ed. You see, that's the thing that.
Oh, yeah.
Right?
Yeah, I
So
see.
mymess.ed.
Yeah, it's good. It's working.
Okay.
Perfect. Thank you so much.
You're welcome. It's very good that you asked, because I'm sure that other people has the same problem. Okay, some other people.
Thank you.
And maybe they are not here, and that's why they are not asking or whatever. Okay, so thank you.
Thank you.
And you're welcome. Yes. Okay, and I think you're seeing my screen now, right? Just to make sure that that's. Yeah, do you see my screen?
Yes.
Okay, thank you. Okay, so we saw two ways basically to import that file. Okay, in one case we imported which one? This one. We imported the whole file, and then so I need to clarify. In both cases that we imported, we load the whole file into memory. The difference is that how we map names. So here we said import mymess, which means I have the mymess name in my code, and so I can access via this mymess, I can access all the functions of that module. Now it only has one function, it will soon have two. When I have in the other way I imported only the add function. So here I can't use mymess. I can't say mymess and mymess, and it doesn't do anything, right? Just as I don't know who talked earlier, but sorry, I didn't see. Just as it didn't work for us before. The other way. Okay, so let me move also the Fibonacci, these two Fibonacci's actually, both of them. The one with the typo as well. Okay, so I'm going to take them and I'm going to move them here as well. So now if I go to the add numbers, I can say mymess dot, and now it offers me all three functions, right? I only use the add, but I could use the others as well. In the original file, I can't use Fibonacci now because I didn't import. I need to import it. And I can do it this way. So I can say, it even offers me to import. Okay, I can do this way. Or I can say, I think I need to put in, I think that's enough. Fibonacci, right. Yeah, that's enough for me because the other one is commented out. So I can run now the Fibonacci file and it works, okay? Because I imported the Fibonacci function as well. So I can use either, I can say from mymess import and I say this and this and that, or I can import the whole mymess at once and then I use via the mymess, I use the functions. Which one is better? It's the same, okay? It's in many code bases, you will see many imports, and some of them comes this way, some of them that way. It's I don't think that's a good idea to mix those two, but I think I do it in every program I write, because most of the time, in reality, most of the time, what we do is go to the documentation, find an example, and copy paste from there, and we start working from there. And so whatever is in that example will end up in our code, even if it's not the ideal way. Okay, so it doesn't matter if you do this or that. This way is sort of, let's say, this way is better because you can have access to every function. Doesn't matter which one. But you have to type in my mess in every place, in every part of your code. So it's sort of a waste of, I don't know, real estate on screen real estate. The other one is good because you don't have to type in all the name, all the my mess here. I don't have to type. But on the other hand, at the top I have to, but on the other hand, okay, I look at this and I don't know where this add came from. Okay, I can click on the editor helps, okay, and so I can jump to the source and so on. So that helps. But just by looking at it, I'm not sure, okay, whether it came from the my mess library or from some standard library or something I installed, or I don't know, okay. So it has advantages and disadvantages. And I can't, right now, I can't use this non-recursive Fibonacci if I enable it, even if I enable it. It says it doesn't know where it is, okay, because I didn't import it, okay. Now, like, of course, I can come here and add as well, okay, and then suddenly this will work. And then one more thing, I could, and I'm sure you will see solutions like this from my math import star. Okay, this would allow it would import everything. So you can see now it works. Everything works as it was earlier. I really against this because this says, okay, just import everything. And what if the person who writes this MyMess library adds a new function, okay? By saying this star, you will automatically import that new function as well, which you didn't really need, okay? And why is it a problem? Because let's say you have this one from MyMess, and then you have also from your mess, okay? Okay, whatever, some other library. Okay, it's of course yellow now because I don't have it. And we are importing this star in both places. Now, let's say this one had a Fibonacci. Okay, a function called Fibonacci. So you were using it. And now the your mess, which you got from someone else, got a new version. And in that new version, they added a Fibonacci function. So now you are importing Fibonacci both from here, my mess, and both from your mess. But because the your mess is after the importing from your mess is after the importing from my mess, this overrides the previous one, and it does it silently. Meaning, suddenly, just because you upgraded the your math module, you installed a new version, you started to use a new version. Suddenly, instead of the Fibonacci you relied on so far, you get the new Fibonacci, which might behave in a different way. I mean, maybe I had the Fibonacci that returns the last Fibonacci number, the right, and the new one behaves like the non-recursive that returns the list, and suddenly your code is broken. Okay, so this star importing with star, even though I see it, and you will see it in some of the common libraries that use this, I really don't recommend this. Okay, so I'm commenting out. Okay, let me just find something Python. I think I saw it here, and it drives me crazy, but I'm too lazy to tutorial. No, here I don't see this. Or maybe not anymore, I don't know. But I recall that I saw it, I think, here. But maybe it was the... Okay, it looks fine. It imports specific things, so fine. Okay, I am taking it back. Not bad mousing by BioPython. Anyway, so you even if you see it in documentation, okay, please try not to use the import star because it will be problematic. Anyway, any more questions before we go for a break? Git status. While I'm doing this. No questions? Okay, so let's have 10 minutes break or 12 minutes break. So it's 2 minutes to 10 now. And so 10 past 10, we continue. Bye in the meantime. Oh, don't forget to like the videos on YouTube. Okay? Bye.